Let's solve TwoSum. Given an array of integer nums and integer target, return indices of two numbers such that they add up to the target. You may assume that each input would have exactly one solution and you may not use the same element twice. You can return the answer in any order. So given an array of integers num and target, which is an integer, we want to return two indices where those two elements sum up to target. And the problem states that there's always exactly one solution and we may not use the same element twice. So how do we do this? So intuitively, we can traverse through each element in an array and compare it with every other element in the array and check if those two sum up to target. Let's code this up. So we've created a nested loop where every time we meet the element, we would traverse through all the other elements and try to add them up to see if they equal to the target. So for example, if we use the first example, when we're at 2, we would go through 7, 11, and 15. And afterwards, we would move to 7 and check it against 11 and 15. And on our last traversal, we would go to 11 and check it against 15 to see if they add up to target, which is 9. So within this inner loop, we want to see if the second element plus the first element equals the target, which means we can find that by subtracting the outer element here and checking if this equals the inner element, which is all the other elements we're traversing through, like this. So if it equals, we want to return the two indices, which is I and j. But j and I also works because it said the order doesn't matter. So let's run this. And as you can see, this is pretty inefficient because the time complexity for this function is n squared times because we're doing a double nested for loop, which means every time we see an element, we go through the whole thing and repeat that for the entire element, which is creating the inefficiencies. So the most optimal solution here is to use a hash map. So we can initialize a hash map, and whenever we see a new element, we can put its index as a value in this dictionary. So for example, when we first see 2, we can store it as 2 as the key and its index as a value in a dictionary. And then when we first see 7, we want to check if there's a complement number, so target minus 7, whether it's in the dictionary. And in this case, since 2 is already in the dictionary, we can return 2's index and 7's index. But in the worst case scenario, we would store all of the indices before we reach the final element. So how do we do this? We can go through a for loop. And if we find that the target minus num, which is the complement, is in dictionary, we want to return current index and the complements index that we find from the dictionary. However, if it doesn't exist in the dictionary, we just want to add its index to the dictionary. So let's run this. And as you see, it's pretty efficient. And we've solved TwoSum.